Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 16, 2026, just 3 days ago. It identifies a critical flaw, where personalized large language models prioritize user history over objective facts, but proposes a fix that improves overall performance scores by over 50%. The paper is titled, When Personalization Misleads, Understanding and Mitigating Hallucinations in Personalized LLMs. And as we'll see later, the implications for building reliable AI assistants are really significant. Figure 1 illustrates the core dilemma using real examples. At the top, a standard large language model answers facts correctly, but fails a personal question about church attendance due to missing context. In the middle, adding chat history fixes the personal query, but causes a hallucination on the factual one, incorrectly claiming Woodrow Wilson because the user recently discussed World War I. Finally, the bottom row shows that factuality-preserving personalized steering successfully disentangles these signals to answer both correctly. Well, Figure 2 explains the mechanism driving these errors. On the left, the vector diagram shows the vertical blue arrow representing factual knowledge. The personalization vector, shown in pink, pulls the final representation sideways, creating factual distortion because the two directions are entangled. To the right, the plots confirm this experimentally. The pink distribution reveals that during hallucinations, the model's internal state is significantly less similar to the factual baseline than during truthful answers, shown in blue, proving the distortion is real. So Figure 3 moves from theory to impact, showing how these hallucinations act in practice to degrade learning. The diagrams at the top outline the simulation. Researchers set up a virtual classroom where small student models ask questions to larger teacher models. On the left, the control group uses a standard teacher, while the right side uses a personalized one. The bar chart below delivers the verdict. In every single case, the blue bars for the standard teacher outperform the pink bars for the personalized one. The legend highlights the damage, an average accuracy drop of roughly 10%, proving that unmitigated personalization actively hinders factual learning. While Figure 3 confirmed the problem, Figure 4 outlines the solution, the factuality-preserving personalized steering framework. This pipeline operates in 3 distinct phases to filter out hallucinations. Stage 1, at the top left, performs offline layer selection by comparing inputs with and without history to pinpoint which layer is most sensitive to distortion. In Stage 2 on the right, the system trains a probing detector on that specific layer to recognize when personalization is interfering with facts. Finally, Stage 3 at the bottom applies this safeguard during inference. The trained prober evaluates the hidden state and, if necessary, triggers the mixed steering mechanism to mathematically correct the vector before the model generates its answer. With the framework established, Table 1 presents the main performance results across 3 different language model backbones. The columns track 3 key metrics: P-score for personalization, F-score for factuality, and an overall average. Take the first group. Using the PAG method on Llama 3.1. The standard baseline struggles with facts, scoring only about 17% on the F-score. But applying the mixed steering method, highlighted in orange, rockets factual accuracy to 75%. Crucially, the P-score stays steady at 46%, proving we can effectively balance adaptation and truth. To rigorously test these models, Figure 11 details the construction of the new benchmark, PFQA bench. It starts in Stage 1 on the left, combining realistic user histories from long-mem eval with objective queries from FactQA. The critical filtering happens in Stage 2, where the pipeline matches specific history sessions to factual questions that are semantically similar. This effectively creates a trap, because the model sees a question related to the user's past topics, but must rely on external facts to answer correctly. Finally, Stage 3 on the right assembles the benchmark, ensuring each user context is paired with both a factual and a personalized question to measure the trade-off accurately. Wrapping up, 2 takeaways stand out. Personalization effectively creates an echo chamber that can override objective facts, but lightweight steering can disentangle these signals without retraining. This implies that as AI becomes more personal, safeguarding truthfulness will require active interference, not just better data. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.